All right, I just put on a recording. Today, we will continue where we left off from yesterday. We were doing quadratic, let's see, according to our latest note, quadratic 4, right? Quadratic 4. We worked up to number 9. Wait, did we? Almost. We almost worked up to number 9. We worked up to number 7, number 7, okay, yesterday. So let's just recap a little bit and, to just review what we did yesterday. We, we have the domain, concavity opening up, right? Because A is greater than 0. And we also found the y-intercept, right? And by finding y-intercept, we know that the curve crosses y-axis at a 1 point, and 1 point only because it is a function. And then we completed a square. Okay, we completed the square. And this completed square form is often used. It's often used. Okay. And then we did the graphing from x squared. Okay, from x squared. And we have identified the vertex from this transition. And we have identified the range. And we have identified the minimum y value. Okay, the minimum y value. And next, okay, so we're gonna continue on this topics today on number 8. Okay, and this is about the line of symmetry, right? So number 8 and number 9, these are about the line of symmetry. We know that the quadratic functions, they're not always even, i.e. they're not always symmetrical with respect to y-axis, but it is symmetrical with respect to something, right? From this shifting process, we can see that we shifted to the right by, we shifted to the left by 1 unit, right? So we ended up here. So that's a line of symmetry. So let me draw that line of symmetry over here. So this shifting, okay, so let me draw the line of symmetry. The line of symmetry. And this is the line of symmetry. I'm going to make it green, broken line, and just stay thin. Okay. That's a line of symmetry. This line of symmetry is the line of symmetry for x plus 1 squared. But the next step we did is we shifted down by 4 units. So the line of symmetry still stays, right? It still stays. So the line of symmetry is still the same. It's still the same. Okay, so we keep it there. So you can see the line of symmetry is entirely determined. It's entirely determined the horizontal shift. Okay, it's entirely determined by the horizontal shift. The vertical shift does not change the line of symmetry. Therefore, the line of symmetry, what is the line of symmetry? Could someone tell me what is the line of symmetry? What is the equation? Okay, so number 8 and number 9, we ask you to draw the line of symmetry, and number 9, we ask you to identify the equation of the line of symmetry. So what would that be? So these two questions, we just want to see if you understand. If you understand, right? Do we understand the equation? So one is draw the line of symmetry. Okay, the next one is give the equation of the line of symmetry. Draw the line of symmetry. I believe everybody can draw, right? So you draw this line of symmetry and then you give the equation of the line of symmetry. Yeah. So what will be the line of symmetry? Let's see if I can see any answers. Yes. What is the line of symmetry? What is the equation of this line of symmetry? Right? The original x squared, right? It has a line of symmetry. That line of symmetry is x squared. Okay, so let me bring these over to, right? That's over here. I'm going to bring it right here, right? So this is the line of symmetry, which is the y-axis before the shifting, before any shifting. So what is the line equation of this line of symmetry, which is the y-axis? What is the equation? Anybody tell me? Yeah. Hello, are you guys awake? Yeah. That line of symmetry is x equal to 0. Okay. Why is x equal to 0? Because every point. Did we address this yesterday? I thought we addressed this yesterday.
Yes, we did.
We did. Do you guys understand what?
Yeah.
We don't have any. We have no.
You want me to see him?
You guys understand?
Yeah.
Oh, okay. If you
Well, I
do,
do.
then I'm not gonna make much ado. Okay, the line, because every point on this vertical line has the same feature, which is the x coordinate is 0, right? So
Yeah,
what's the equation for this green broken line?
one.
What? Sorry, I'm sorry.
The x coordinate being the -1.
X equals to
-1.
Very
Yeah.
good. Very good. Okay. So very good. Okay. And after the final shift, what is the line of symmetry then?
Then this is -1, 0.
It's still I mean, this line of what line? What is the equation of this line?
That's negative. Which one? The green one? It's
The green
-1.
line. It's still x equals -1, right?
Yeah.
Absolutely. You can see the line of symmetry is entirely determined by what?
The x.
By the horizontal shift.
Oh.
Right? By the horizontal shift.
Okay.
Do you guys see that?
Yes.
So that's why when you look for the line of symmetry, when we look for the line of symmetry, what do we do? What do we do? We just have to look at what is the horizontal shift, right? What is the horizontal shift? And that horizontal shift is told by the square part, right? Yes?
Yeah.
The square part. So the line of symmetry, it just x equals to -1. Got it? Is everything clear?
Yes.
Visual, nice, right? You know what things are, right? And you can mark each one of the curves and so on and so forth, right? So let's continue with the next group of exercise. Okay, the next group of exercise. The next group of exercise, we started with number 10. Okay, number 10. Find x-intercepts. intercept. This time, there might be plural. Why there might be plural? What is the meaning of x-intercept? Okay, what is the meaning of x-intercept? Okay, so I'm going to take this picture. Now we can take this picture, right? We can take this picture with us, right? I'm going to remove the green and black, right? We no longer need them. We remove that. And we remove that as well. Okay, we just have the green, we just have the red, and well, we can just keep it red, okay? Now, so this is our final curve, and we have identified the lowest point, the vertex. And next, we want to identify the x-intercept. Excuse me. We want to identify the x-intercept. So where do we find the x-intercept? That's where the curve crosses where? Crosses
the X line.
x-axis, right? So that the name itself is self-explanatory. And what do these points on the x-axis have in common? Right, so how do we find x-intercept?
y0.
That's right, because every point on the x-axis, those points, the x value we don't know, but the y value, the output is 0. So finding x-intercept really is looking for inputs such that the outputs are 0, right? So these two, I'm sorry?
So it would be what makes the equation 0, right?
That's right. We're going to make the entire curve equal to 0, i.e. the function, the curve crosses with x-axis. And what is the equation of x-axis? What is the equation of x-axis?
Y = 0.
That's right. That's right. So that's why we said y = 0. Okay, so you don't have to memorize. You want to visualize. You want to understand. And then you never have to memorize. You never have to memorize. Okay, so with that said and done, so let's get started. Okay, we said y = 0, but what is y? Right? And we see that we see that y has many names. Okay, y has many names. Y is the function. Right? Y is the function. And y is also this given function, right? And this, that's right, y is the output. And this is also, we have another form. So y has all these different names. Do you follow me? So when you set y = 0, it's the same as you setting f of x = 0. Okay, it's also same as you're setting this guy equal to 0, or you're setting this guy equal to 0. It's as if you're setting, you have all these choices. We have all these choices, and this is output, and this is output, this is output, and this is output. We're setting them equal to 0. So we have a choice, right? So which one do we choose to use to solve for our x-intercepts? So we can choose any one of them. Right? We can choose any one of them. Do you guys follow me? So which one do we choose? And I actually want to choose this guy. Okay, we can use this guy. Solving this equation using this guy. Could I use the other one? Yes, you can use the other one as well. You can use the other one as well. Okay, so let's first use this one to see what we see what do we get. Okay, so we're going to solve for x from it. So this is really an if statement, right?
-1, yeah.
This is really an if statement. Just to go back to our grammar, right? We talk about there are two kinds of statements, right? One is just a statement. The other one is if statement. So this if statement says, well, if the output is 0, you follow me?
Yep.
If the output is 0, let's find the input. That's the context we're in. And then we just do x plus 1 squared equals to 4.
Then
And
square.
then take square root. Very good. Right?
Plus or minus 2.
That's right. Are you guys working on it?
Yes.
Sounds like it. Okay, I'm so glad to hear that. Well, you guys, you can still not see my haircut. You cannot see my beautiful haircut. I'm sorry. I don't know why the Zoom cannot detect my video. Something was wrong. But anyway, so absolute value of x plus 1 equals to 2. So we just go by the steps, right? And then we have x plus 1 equals to plus or minus 2. In the end, so we really just we have 2 x values, right?
Yep.
2 input. One is x1, which is, okay, let's do one more step here, right? I'm going to subtract 1 on both sides. Okay, we're going to subtract 1 on both sides. So it's -1 plus minus 2. Right. So did you guys find your number already?
Yeah, -1, and then it's what's it called?
So 1 is -1 minus 2, right?
Yeah.
Which is a -3.
The other one.
And the other one is x sub 2, which is a -1 plus 2. So we ended up with a 1. So we got 2 points. So if the output is 0, right? If the output is 0, and we got 2 inputs. So and these are the x-intercepts.
Yep. For the x-intercepts are what's called -3 and 1.
Yep. Let's mark those points in our picture. Okay, let's mark those points in our picture. So -3, 0, comma.
And 1, 0.
1, 0. Wonderful. You guys are following very closely. Am I too slow or you guys very comfortable?
I'm comfortable.
Good. So let's mark these points, okay? So far, we're going to summarize. We mark the 2 new points, and we're also going to mark the vertex, and we're going to mark the y-intercept. How about that? We have achieved so much, right? So we're going to mark these points, okay, with red dots. Are you guys doing that? Okay, so let's mark these points with red dots. And what's our y and one more, the vertex, right? -1, -4. Ooh. We have all these 4 points, right? So we first find the y-intercept because that's the easiest. And we did completing a square. We found the vertex, and then we found the x-intercepts. 4 points. 4 points. Okay. And I want each one of us to mark these points on your picture. Okay. So as a good habit. Okay. So here we're going to mark the -1, -4. That's our vertex. It should be at -1, -2.4.5. Okay, are you marking those, you guys? Let's do that. -1, -4. Right? So mark each one of them. Mark each one of them. Okay. And this is a 0. -3. We're marking 0. This is -3. And the fonts. And this one, I'm going to use the green. And the two x-intercepts. The two x-intercepts. -3, I'm sorry, -3, 0. I put this as a -4, 0. Okay, that's good. One more. 1, 0. Sorry, 1, 0. So 1, 0. Finally, we have marked them all. Okay, another perspective. Another perspective. You see, when we are looking for y-intercept, we were using the y-axis, which is x = 0, to cross the curve. When we're looking for x-intercepts, we're taking the x-axis, which is y = 0, to cross the curve. We get 2 points here. Now, we have all of these points, okay? And from number 11, we're going to see another series of questions, okay? The first one, let's look at number 11. 11 says evaluate, okay? F of 0. We're going to do a comparative study with 11 and 12, okay? 12 says solve the equation f of x = 0. For x. Okay, so these are the typical questions that bothers our students. They couldn't tell the difference. What is the difference here? What is the difference between question 11 and 12? Does anybody know?
For 11, you're making the x = 0, and then for fx = 0, you're making the equation = 0.
Right. So in terms of input output, what's the difference?
Input is 0, output is 0 for
Very good. Did you guys see the reply in chat and what you just said? Very, very good. Yes, the difference, whether the 0 is inside versus outside, the difference is that in this case, okay, 0 is the input, and that's given to f of x to produce this output. The output is f of 0. Okay, and in number 12 is we don't know what's the input. Solve for it, right? And still the same rule, but we are given the output is 0. The output is 0. So that's the difference. Do you guys follow me?
yes.
That's one major difference from the functions perspective. And how about from the geometric perspective? The geometric perspective is that when we given x = 0, the input = 0, we basically draw the vertical line x
Yeah, the
=
y-axis.
0. That's right. We basically draw. So this is the meaning from functions perspective. And the other meaning is that when we have f of 0, okay, the geometric perspective. The geometric perspective is telling us that since the input is 0, right? It tells us input x is 0, input x equal to 0 is a vertical line, right? Do you guys follow me? Everybody? I know
Yes.
I think some of you understand, but I just want to make sure everybody is following. So I'm kind of, still go over this. X equals 0 is this vertical line, right? This vertical line is a y-axis. So we basically taking this vertical line to cross the curve, or you can say to cut the curve. Okay, so that's y-intercept. Do you follow me?
Yes.
So the other thing is f of 0 is something, okay, the input x equals 0, this vertical line. So let me just write it down, okay? This vertical line x equals 0 crosses with the curve, the parabola. Okay, and the point of intersection is the output will be the y coordinate of the point of intersection. All right, so now we understand that it meaning, and f of 0, does this look familiar? Did we do this before? Did we do f of 0 sometime before?
Yes.
When did we do it?
For the y.
When we were looking for y-axis, or y-intercept, right?
Yes.
That's right. So question number 11 and question number 3 are really the same question, aren't they?
Yep.
Am I right? Number 3 is to find y-intercept.
Yes, you are.
That's right. You can see they're different question, but they're the same question, just asked differently. Yes.
Yes.
So f of 0 is -3. Got it?
Yeah.
Did I make you feel drowsy?
No,
No, you did, or you didn't have enough sleep.
I didn't have enough sleep.
Okay. All right. I'm glad you're here. Okay. I'm glad you're here. All right. So number 12, right? Number 12. So we're setting f of x equal to 0, right? We're solving for, given the output is 0, we're looking for input. Geometrically, okay, f of x equals 0, meaning f of x equals 0, whoops, f of x equals 0, and the scenario is that the line of y equal to 0 crosses the parabola. Crosses a parabola. Do you follow me?
Yes.
So that it's more like you're given y equal to 0 because the output is 0, the output is y. Got it? Now, the question is, we ended up solving this equation. Doesn't this equation look familiar?
Yep.
Have we done it before?
Yes.
When?
When we did the x-intercepts.
That's right. Very good. So number 10 and number 11, number 10 and number 12 are exactly the same question, aren't they?
Yep, exactly.
They're exactly the same question. So I can totally just copy and paste this piece, right? And we're done. You guys follow me?
Yes.
Now, we're going to see if you truly understand this piece, okay? So the remaining questions that we have, number 13 and number 14. Number 13 and number 14. Okay, they're paired. You can see 13 and 14 are paired. 15 and 16 are paired. Okay, 17 and 18 are paired. So we have 3 more of similar scenario. Do you think you can handle it?
Yeah.
All right, so maybe we should do it together, right? So let's look at 13 and 14. Ready? 13. Okay, so we want to understand the meaning, not only from, want to understand the meaning from functions perspective, the geometrics perspective, and we also have to do it, we have to be able to solve it algebraically. So there are 3 aspects, okay, 3 aspects. First one is f of 1. Sorry, f of 1. Okay, it tells us to evaluate f of 1. Okay, and the next one is solve the equation, okay, where we're going to create an if statement for x. Tell me what the difference. If you understood 11 and 12.
Input, output.
That's right. So they're very, very similar. They're very, very similar. The only difference is that the input in 11 is 0. The input in 13 is 1. So what is f of 1? We just plug in, right?
Yep.
So x equals to 1. And the end, what do we get? It's 0, right?
Yep, 0.
So what is the geometric meaning?
That one is x.
F of 1.
F of 1 is.
It's a vertical cut, right?
Yep.
It's a vertical cut. So we are going to draw a vertical line. Okay. The vertical line crosses the curve. Okay, the vertical line crosses the curve right there, right? The vertical line. We're given f of 1. So x is equals to 1. X equals to 1 is the equation of this green line. So can you mark that? Does everybody follow me? I know we're repeating quite a few times, but I hope I don't get you bored. It's very important to understand this. Green. The cutting vertically. And the crossing is 1, 0. Do you follow me? So f of 1 has a geometric meaning. Okay, vertically, a vertical line, x equals to 1, x equals to 1, crosses the curve, and the result, the output is 0. So that's 1, 0. Got it? Everybody? That point is already marked. That point is already marked. Okay, it just happened to be one of the x-intercepts, right? Now, f of x equals to 1. Suppose we still use this perfect square equation, right? The one with the perfect square, minus 4 equals to, this time is equals to what? 1. Does everybody follow me? So we're drawing a horizontal line. We're drawing a horizontal line. This horizontal line, okay, is going to be 1. And we're going to use red to do the cut. Horizontal line. Horizontal line. Okay, so f of x equals to 1. We were looking for the intersections. The intersections. How many intersections do we have here?
2.
We have two. One is here, right? And one is here. Okay, by solving this equation, we will be able to identify the x coordinates of these 2 points. The y coordinates of these 2 points are already known, right? They're just what? 1, right? And this other one is going to be, you know, question mark, and we don't know, and the y coordinates is 1. So by solving this equation, by solving this equation, we will be able to identify these 2 hearts. You guys follow me? So can we find those? Can we find those? Are you guys working on it? Yeah? So let's do it. Let's do it. So we're going to go through the steps. Okay. Adding 4 on both sides. And we have x plus 1 squared equals to 5. And take square root on both sides. Take square root on both sides. And we get absolute value equals to root 5. And then x plus 1 equals to plus or minus root 5. So in the end, we get x equals to -1 plus minus root 5. Someone wants to say something? Go ahead.
No, you said it.
Okay. You got it? This represented 2 numbers as well, right? One is x sub 1. Oops. X sub 1. And the other one is x sub 2, right? -1 minus root 5. And the other number is x sub 2, which is -1 plus root 5. Okay, so what are the points of intersection if we are asking for it? You can say the line y equals 1 crosses the curve at 2 points. One point is -1 minus root 5. Don't worry too much about the numerical value, okay? You know, just use it as is. That's the most precise one, okay? That's the precise one. So these are the 2 points. Does everybody follow me?
Yes.
And where do these 2 points go? These 2 points would go
On the one.
That's right. Graph. Go to the graph. Okay. 1 point, 2nd point. Boom. These looks a little bit crowded, but I still want you guys to mark the points. I'm going to mark the points using the Zoom software, so it's going to be temporarily marked. But as an exercise, I insist that everybody should do this. So this point, let's mark it. Okay, so that point, let's make it center. Okay, it's -1 minus root 5, comma 1. And this other point, okay, is -1 plus, forgive my writing, okay? Root 5. If I use the software, it still doesn't, it just doesn't write the root 5 the way I want it. I have to write SQRT, okay? All right, does everybody follow me? Is that good? Is that clear enough?
Yes, very.
Do you think you want to do 15, 16 ahead of me? You want to do 16, 17 ahead of me?
Yeah, yeah, we could.
Okay, how about I give you a couple minutes? You understand the process? Okay, if you understand this process, the same process applies to every function. It doesn't just apply to quadratic. It applies to sine, cosine, tangent, cotangent, any function, every function you will encounter in the future. However complicated, however simple, same thing. Okay? That's the beauty of understanding one thoroughly, you understand all. Understanding one thoroughly, you understand all. Of course, there will be more complicated situation, right? But understand one, you understand all. It's just a matter of applying them. Okay, this is also the reason why I'm going kind of slow. Do you think I'm going too slow? Please complain if I'm going too slow.
I think it's fine.
It's fine. Not too slow because I don't want to put you to the point that you want to take a nap. No, not yet. Not yet. Okay. Okay. $15, $16. Okay, $17, $18. Could I put these away? Okay, I'm going to put them away. Okay. I'm preparing for 15, 16. Oh. If you finish the 15 and 16, go ahead to do 17 and 18. Okay, 17 and 18 has there's a little difference in there, but I want you to experience that. Okay, yes, the ideas are similar, but there's some other interesting aspect to it. Have you finished? Have you finished the 15 and 16? So the 2 points I got is -1 minus √6, 2, and the other one is -1 plus √6, 2. And this is a little too busy, but I trust you can mark them. You can mark the points. Yes, you can mark the points. I marked the crossing vertically 2,5, 2,5. Okay, for 15, and you know, I make them the color tone so you can see when the input is given, they're vertical cut. The vertical cut are all green. The horizontal cut are all are red. Does everybody follow me? Good, is that clear? Okay, let's see what happens at 17, 18. 17, 18. The ideas are pretty much the same. The idea is the same. Okay. F of -5. Okay. And the other one, of course, is solve the equation. It's an if statement. F of x equals to -5 for x. Okay, so if we I think this is too busy. We need to stop working on this one. Maybe it's not too bad. Should we continue to do this? I think we're fine. Which one should I use? We can use this one. Okay, we can use this one just one more time. Okay. When we draw the vertical line, okay, when we draw the vertical line, okay, the green. Does it touch the y-axis? Does it touch the curve? Do you think it's going to touch the curve? Yes, it's going to. The only difference you don't see it is because my line was not drawn long enough, right? If I make adjustment and we see more view, we see more of the views and we will see it, right? So I'm going to just make it a little bit longer. Okay, and I'm going to adjust the view as well. Okay, so maybe 14. There, it's going to touch the curve, because input can be any real number. Of course, it's going to touch the curve. Of course, it's going to touch the curve. Sometimes we don't see it touching is because, you know, we need to adjust the view. We need to adjust the view. So what do you get here? Okay, be very careful when you do this operation. Sorry, not to the power 3 squared plus 2 times -5 minus 3. Okay, so we have a 25 minus 10 minus 3. So we get 12, right? So that point is -5, 12. Okay, and this vertical line you can mark, right? Okay. How about the other one? What happened to the other one? What happened to the horizontal cut? What happened to the horizontal cut? The red. The horizontal cut is beneath the entire curve, right? That's easy to draw. But what will happen algebraically? Something interesting will happen algebraically. So are you guys there yet? So what did you get? Algebraically, okay, we still have this x plus 1 squared minus 4 equals to -5. When we are trying to solve this equation, Okay, we add a 4 on both sides. On the right-hand side, we have a negative number. Does any one of you know about complex numbers? That's right. So this is the situation. We're going to have a complex numbers. The quadratic equations still have solution, but the solutions are complex numbers. So when we have complex numbers as solution, what does that tell us? It tells us no touch. It tells us no touch. So then you say, how about the complex number solution? Well, our rectangular system, the system as we work with right now, cannot accommodate complex numbers. That's why there's no place for it. There's no place for it. So when you solve a quadratic function, a quadratic equation, some of you might, still remember what you had learned before, is that when you have a complex numbers, that means there's no real number solution. So you can still get here, okay? You can still get to the absolute value, and that equals to I, right? And you still get a complex number solution, okay? So what you do, you just say, well, this equals to plus minus I, okay? You can still complete this process, okay? And you will tell the reader there's no real number solutions. That is the line. Okay, we started with y equals -5 does not touch the parabola. Okay, the line does not touch the parabola. Okay, and then you say, well, does this equation have a solution? Well, you can also say the equation, okay, so these are different wordings you can say, okay? The equation has a pair of complex number solutions. Okay, so these are the wordings and these are the terminology you can use. And of course, for different questions, they may be asking for you different things, okay? And this is what happened, there's no touch. This is what happened, there's no touch. Okay, I'm not marking these other things because that takes time. And we're gonna move on to the next questions. Okay, next set of questions, which is from number 19 all the way to the last one. Okay, so let's see number 19, 20, 21, 22. This is one set of question. Okay, this is one set of question. So number 19, 20, 21, 22. Okay, for all of these questions, they have similar wording. We have similar wording. Okay, we have similar wording. And that similar wording is solve for. So they're all if statement. They're all if statement. Okay, solve for x. Okay, from where? From f of x equals to x squared plus 2x minus 3. And we want it to be larger than 0, if that's larger than 0. Okay, number 20, larger than or equal to 0. Okay, and less than 0. Right, you see there, from the grammar's perspective, the structure of the sentences are similar, right? Okay, so what does this all mean? What does it mean? Okay, so I'm gonna, forgive me, I'm gonna bring a picture back to us. Okay, I'm going to bring this picture back to us. What do they all mean? Right here. This question number 19 says, from the function's perspective, okay, we're solving for x, so we don't know the input. We don't know the input, okay? And we know the input is still given to the function, right? The function still processes the input. So that's our function. Okay, solving for x meaning that we're going to have a specific requirement on the output. What kind of output do we want? We want positive output. Do you follow me? Now, where do we find positive output from the picture?
Above the x-axis?
That's right. That's right. So, could you repeat that so everybody can hear you?
The positive outputs are above the x-axis.
That's right. Okay. So, this piece of curve tell us they are positive output. Positive output. So we have two pieces, positive output. So how about the one underneath? Negative. So we want to identify all the input. So this question number 19 is really about to identify all the possible input such that the output, their outputs are positive. Does that make sense? So how about these two dots? These two dots. Well, what does these two dots say? The dot 1, 0 says when input is 1, the output is 0. Obviously, that's not fitting to be positive, right? Therefore, these two dots should turn to what? They should turn to two circles. Okay, they should turn to two circles. Okay, one more circle. Do you guys follow me? Two circles. And so where do we find all the input that will make the output positive? That's over here, right? Let me make it thicker. All of these here, that's where you found those input, and that's where you found all the input. So we have many, many solutions, don't we? These inputs will make the positive output. Does everybody understand? Once you understand the issue, you understand the question, the answer is obvious. The answer is obvious. Is the answer obvious to you? Can you write down the solution? Can we write down the solution? The solution for number 19 would be what? Would be x less than -3 or x larger than 1. Does everybody follow me? Yeah? Now, how about number 20, 21, 22 then? Yeah? Do you have a clue? I'm sure you do. I'm sure you do. Okay, I'm gonna make some adjustment to this picture because some of those points we don't need, I'm gonna remove them, okay? For example, we don't need the vertex. In this process, we don't need the vertex. Okay. And we don't need the y-intercept either. Okay. So I'm going to remove those points just for simplicity. Okay. Just for simplicity. -1, -4, delete. 0, -3. 0, -3, delete. Okay. So nice and clean. Nice and clean. Positive piece, positive output, positive output. Negative output. Do you follow me? 0 output. Does everybody follow me? Positive output, positive output. Negative output, 0 output. Isn't that everything so crystal clear? So can you work out a solution for 20, 21, 22? Okay. So meanwhile, I'm going to put a summary table together for you. Okay, you work on 20, 21, 22. Okay, really play with the picture. Okay, so I'm going to put a summary for you in the circumstances. Okay, so for this guy, solve for x. Larger than equals to 0. I'm going to make this fonts a little bit smaller. And this guy less than 0, less than or equal to 0. Picture. I don't think I need the vertical line in the middle either. Okay, so I'm going to remove that. Okay, I'm just trying to make it clean. Okay, so to solve this kind of inequality, you really just need x-intercepts, if there's any, okay? The reason why I say if there's any, because sometimes there's no x-intercept, as you're gonna see those questions in the future, okay? And for this one, there will be dots. There will be dots. Okay, so this time there will be dots. Dots. Okay. And for the other two situation, what happens, you guys? For the negative one.
It's under the x-axis.
It will be right in the middle, right?
Yeah.
So I'm going to make some adjustment to this picture. Okay, delete. Wait, delete. And then we're going to add -3, 0, 1, 0. And the line thick. Okay, that's less than 0. How about less than equal to 0? That will be the dots, right? Those will be the dots. The next one is do you know how to express the solution algebraically? The picture we understand, right? We understand the picture. But how do we express it algebraically? How do we express it algebraically? We have the first one, we have the solution for the first one, number 19. right? How about the second one?
It would be the same thing, but instead of less than or greater than, it'd be less than or equal to, and then greater than.
That's correct. How about the third one? Less than 0. That'll be -3 less than x and less than 1. And over here is -3 less than equals to x less than equals to 1. And we don't need that row. So do you think this summary is helpful? It's all about input output, aren't they? Yes? So now we reflect all we have done this semester. Different rules, but it's all about input output, 2 sentence structures of, of grammar, grammarly speaking, just 2 kinds of sentences. Okay, all of these are if statements. All of these are if statements. Okay, so how about 23, 24, 25, 26? '23, 24, 25, 26. 23, 24, 25, 26. Okay, still solve for x. What are they? What are they? They are just algebraic variations of what we did, aren't they? Aren't they? If you look at number 23 and number 19, these two are actually the same statement, aren't they? Yes. And they're just algebraic variations of it by adding 3 on both sides, you get 23, right? By adding 3 on both sides on 20, you get 24. Do you guys follow me? By adding 3 on both sides of 21, you get 25. By adding 3 on both sides of 22, you get 26. So they're just algebraic manipulation using principles, right? Using the 1, 2, 3, 4, 5, 6 principles, using some of them. And the consequence is 23, 24, 26, 23 through 26. Do you guys follow me? If you got those, right? So these equations, these inequalities, if I add some rows, right? If I add some rows, and they have some algebraic variations, right? They all have their own algebraic variations, such as x squared plus 2x greater than 3, right? And we're actually not limited to these algebraic variations, right? You can vary some more, right? You can move the 2x on the other side and so on and so forth. Does everybody follow me now? Isn't that interesting?
So it would produce the same solution?
That's right. That's right. Now, if you understand this, go back to look at 10a. Go back to look at 10a. Do you see 10a in a new light? Or at least do you start to see 10a in new light? Remember, I was talking about, I'm going to talk about 10a and everything quadratic together. Do you think you understand why I'm doing that? A lot of those are same questions in nature. Do you follow me? In 10a, I covered a method which is different from the method we did here. But that is based on if that quadratic can be factored, right? Remember the first example we did, that can be factored. And these questions we did, these methods can also use to solve 10a. Can also use to solve 10a. Okay? So does everybody understand all the questions here? Okay, so I'm not going further on quadratic. We're going back to 10a. Anybody has any questions? Okay, because I really want you guys to understand this. Okay, then you start to see simplicity. You start to see simplicity. Okay, so let's go back to 10a. Are you ready? Basics 10a. Once again, revisit it. Revisit. Can a revisit? The first question in 10a, what was it? Do you guys still remember that question? Was x plus 2, x minus 3, something like that? Yeah? A. X plus 2 times x minus 3. We want it to be less than 0. Right? We know it's an if statement. And we solved it using that sign thing, right? We solved it using a particular method. Then you say, does that method work all the time? And it does. Well, sometimes it doesn't work, or sometimes it's hard to work to make it work. Okay, so we also talk about this other method by doing the quadratic, right? So when we were doing this number 1 in 10a, we used both. We used 2 methods actually, didn't we? Could you guys go back to look at the notes? We used 2 methods. One is by the sign, right? Plus, you know, you work with the sign of x plus 2 and so on and so forth. Remember that? Okay, we use 2 methods. The first method, okay. The second method we did is that we use the graph, didn't we? Right? We use the graph. We graphed it. We graph these. Right? And there's 2 points of crossing. The second method is exactly the same method we used today, didn't we? For alpha, or for quadratic 4, is that right? Right? Does everybody follow me? Isn't this interesting? It's all about input output, right? So at the time we have this, you know, we have these dots, right? We have these circle, right? And add another one, right? We have these 2 circles, and this is a plus. This is positive piece, negative piece. So you can solve it using 2 different methods. Then you say, do I have to learn 2 different methods? Well, in this situation, you can use either method. And there are more methods. Trust me, there are more methods. Okay, I only just show you 2 methods. Okay, there are method number 3, method number 4, and textbook offer you another method as set up the table and stuff. But what if the factoring is difficult? Okay, so now we're revisiting 10A. We're revisiting 10A. Okay, so we're going to look at some more questions in 10A. Okay, we're going to look at more questions in 10A. Okay. With that review behind us, I want you guys to pick up some questions, because in 10A we have some quadratic functions, quadratic inequalities. We also have some quotients issues. Okay, we haven't touched them yet. So we're going to be back in 10A. This revisit is going to last, tomorrow we're going to still be on this, right? Did you guys finish 10A? 10A was given to you as homework, right? Yes? Did you finish? Did you guys finish? I imagine probably not yet. You did? Oh, right. Cortland he said he finished, and Mikhail's finished as well. That's good. Okay, I need to check on your work. If you finished, that's great. But we need to revisit some of these questions, just make sure, right? Just to make sure. Now, so let's choose another question in 10A. Okay. For example, I would choose number 6 as a new question. Okay, we have we don't have much time left. We have like 11 minutes, but I think we can revisit these. Okay, so x squared less than 2x plus 8. So let's solve this inequality. Let's solve inequalities. Okay. I want you guys to understand all methods, all these methods, all these 2 are basic methods, even though I still, there are other methods might pop up when you solve these inequalities, as you guys are doing it because you have learned it somewhere else. But I'm totally open to any method you want to do, because every method opens mind. Every method opens mind. Okay. But because in class we have limited time and we have limited, energy. But for you, I encourage you to explore those different methods. Okay, they will all open your minds and make you better. Okay, so solving this inequality, what would you do? What do we do? We're done number 1. And we've done all the quadratics, right? We've done one big question of quadratics. And what do we do with this guy? I'm going to move forward though. Okay. Well, one of the ways to do it is to make 0. Right? If you notice what we did with number 19, 20, 21, 22 in quadratic 4, you can see one side of the inequality is 0, right? You want to say, okay, I want positive output, I want negative output, I want positive or 0 output, and so on and so forth. And number 1, you have a product compared with 0. So all of these tell us that we can convert to those questions. So we're going to do some algebraic manipulation. So minus 2x minus 8 less than 0. So this is more like it, right? So this step, I call it make 0. You follow me? You certainly can imagine this is a quadratic function. Okay, you certainly can imagine this is a quadratic function. Whether you write it down or not, it doesn't matter. So this question, if you imagine this is a question, and this question is similar to quadratic 4, isn't it? Do you have to do this? You don't have to do this. Even if you don't do this explicitly, in your mind, you should have that reflex. We want to have that reflex. We have that connection. Okay. For example, you can do this different ways. I'm going to just put these ideas out there since you have seen all these different ideas, right? So I'm going to factor. I'm going to factor. Okay. So making 0, and this is make product. By making product, I'm setting myself up to use principle number 5 and principle number 6. Remember the method we talked about for number 1 is using principle number 5, or principle number 6, right? So basically we see this as a product A times B less than 0. We want to have a negative product. Right? We want to have a negative product. And therefore, we observe the sign of x plus 2. Okay? And we make the number line at a negative 2. Sign changes, right? We understand sign changes, right? So I'm not going to go over that all over again, right? So for x plus 2, when x is less than negative 2, they're all negative. At negative 2 is 0. After negative 2 is positive. You guys follow me? Do you still remember this? I hope you haven't forgotten. I hope you haven't forgotten. Yeah? 0. Okay? And then you work with the sign of x minus 4. Okay? Once again, number line and positive 4. Number line. Okay? And then to the left, when x is less than 4, x minus 4 are all negative. When x is 4, x minus 4 is 0. When x is larger than 4, x minus 4 is positive, right? So in the end, we look at the sign of the product. And of course, we want the product to be negative, right? And once again, the number line, we have negative 2, right? And we have positive 4. The whole drill that we have done, right? And the product is going to be what? When x is negative, less than negative, that's going to be positive. Very good. Okay. And at a negative 4, a negative 2 is going to be what?
0.
0. And between negative 2 and the 4, negative. I'm glad you guys still remember, right? And afterwards, it's positive. Right? Remember we did this, right?
Yeah.
So now this is what we wanted, right? This is the if statement we have, and therefore the solution what? the solution is what? Solution is the solution to that, right? That's -2 less than x and less than 4. Got it? All right, so now let's look at the other methods. Let's look at the other method, right? If we did all of these, okay, we assume this is a function, explicitly or implicitly you introduce it, and we want that to be less than 0. So if this is true, then this is true, right? And then you're going to just graph this. We're just going to graph this. Yeah, do you guys follow me? Okay, and of course we have identified the points of intersection, right? We have identified the point of intersection. So these 2 points will be identified along the way, right? One is a -2, 0, and this has to be a circle. And the next one is 4, 0. And that's also going to be a circle, yeah? And we understand this piece is a positive, right? This piece is a negative. So what is the solution? So solution to what? To that inequality is what? It's still -2 less than x less than 4. You follow me? Now, the next thing I want you guys to see, look at these 2 graphs. Hold on. This picture doesn't listen to me. Okay, so what I want you to see is that this picture, if you put these 2 side by side, if you put these 2 side by side, what do you see? These positive corresponds to what? Corresponds to this positive piece. Do you guys see that?
Yes.
And this positive piece corresponds to these positive. Do you guys see that?
Yep.
And these are negative.
Got it.
Are they consistent or what?
Very consistent.
Isn't that simple?
Yep.
We start to see some simplicity.
Mm-hmm.
Definitely see it.
Huh?
I can definitely see it all making sense.
That's right. I'm so glad to see that. I'm so glad to hear that, even though I cannot see you guys. Well, you guys could show up your face, but for some reason I cannot show mine. You cannot see my perfect haircut. But anyway, I hope this connection will help you to see some more simplicity. If I tell you, in a lot of the functions you are going to be dealing with, the rules are different, but the ideas are the same. Ideas are the same. Isn't that nice to know? Yes
Yep.
or no? Isn't that nice to know?
Very nice.
All right. So you got work to do to deepen your understanding. I will assign you homework, and today, sometime later, you have a quiz coming up your way. And I hope today's lecture and all of my lectures are helpful. And if you have any questions, so please don't hesitate, okay, to send them my way. And I'm looking forward to it, okay? So that's all for today. And I'm going to jump to my office hour. And if anybody want to see me then, just feel free to come.
Okay.
Thank you.
Thank you. Very good job. Very good
Terrific.
participation. Thank you, guys.
Yeah.
Have a great day.